Hi everybody, welcome to day 4. So today we're going to be talking about electrical circuits. So what is an electrical circuit? An electrical circuit is a path along which electricity can flow. So there's a diagram on the website here. Today, kind of like yesterday, it'll be really important to follow along on the website. But this first picture on the website here, it shows there's a diagram of a simple circuit. So on the left side, we have a battery, and we have a wire that goes from the battery into a switch, and then from the other side of the switch along a wire to an LED, so a light, and then the wire comes all the way back around and into the other side of the battery. So in this circuit, electricity flows from battery through a switch, through a light, and back to the battery. So circuits are always either open or they're closed. So in our diagram, our circuit is open. So that switch that we have in our circuit, you can see that it doesn't connect from one side to the other. So a circuit that has an opening that prevents electricity from flowing all the way around is called an open circuit. So that switch, just like like a light switch at your house, when you turn the switch on, it will complete the circuit and allow electricity to flow all the way around. So a circuit where electricity is able to flow from one end to the other in a circle is called a closed circuit. So resistance is a measure of how much a material opposes electricity flowing through it. So materials like wood and rubber and glass, they have a very high resistance to the flow of electricity. So we call materials that don't conduct electricity very well bad conductors. On the other hand, you have materials, especially metals, so like copper, silver, and gold. They have a very low resistance to the flow of electricity. So metals are good conductors. That's why we see most electrical circuits are made with metal wire. So our bodies can also conduct electricity. We aren't very good conductors, so we're not like metal, but we do have a lot of water in our body, so electricity can't flow. So we can actually use our microbits to test that, to test whether or not our bodies can conduct electricity. So I have some code here on the website. There's a picture of it and a little explanation, but go ahead and pause this video and create a new project in MakeCode and get that code up. And then once you have that code written and downloaded onto your microbit, go ahead and unpause the video. Alright, so hopefully you're able to get that code downloaded to your microbit. So I'll just kind of demonstrate here what you can do to, well, let's explain the code first. So we have this forever loop, right? So the code is just going to run over and over and over again, and it's never going to end. But then we have an if pin 0 is pressed, so we have this little 0 on the bottom left of our microbit, so that's pin 0. So if it's pressed, then light up all the LEDs. Else, so if it's false, if pin 0 is not being pressed, then turn off all of the LEDs. So the way that the microbit knows if pin 0 is pressed is if there is a circuit going from pin 0 over to this ground, which is kind of like the other end of the circuit. So if there is electricity that can flow from pin 0 over to ground, then the pin is being pressed. So we can demonstrate that. So if you hold the ground pin with one hand like that, and then you grab the pin 0 pin and you pinch it, then you'll see that the circuit comes on and off. So what's actually happening is that a tiny amount of electricity is flowing from pin 0 around your body and through your other hand, and it's ending in the ground pin. So we're making a closed circuit, and that's what lets the microbit know that the pin is being pressed. So if you took one hand, instead of holding the ground pin, you held like this rubber wire. So remember that rubber is a bad conductor of electricity, and then you tried to push this 0 pin. The lights wouldn't light up because we have an open circuit. So electricity is flowing into this hand and around your body, and then it gets to this hand and you're holding a rubber wire, and rubber doesn't conduct electricity, so it's stopping the flow, and we have an open circuit. But then if you go back, move this finger back to the ground pin and hold this one, then you'd see it lights up again. So we're actually completing a circuit with our body. There's a video here that I have that's kind of an optional activity. We didn't give you extra alligator clips, but you can also just replace all of the wires in this video with people. So if you can get a friend or a parent to help you, you can do this activity, and instead of connecting wires, you can just hold the pins and hold the piece of fruit. So kind of another example, but a pretty cool demonstration of how electricity flows. And in this case, he uses an orange, but fruits are made out of a lot of water as well, so they also conduct electricity. So we've talked about circuits that the main goal is just to get electricity to something, right? So to a light. In the diagram above. So just like a flashlight, the point of a flashlight is to get electricity from batteries to a light bulb, and then it comes back around and makes a circuit. So another reason why you would have an electric circuit is not just to power something, but also to convey information or to transfer information. So there's two main ways to transfer information in a circuit, and we call those analog signals and digital signals. So let's talk about analog signals first. So one way to transfer information in a circuit is just to vary the amount of electricity that's flowing. So you could imagine like a dimmer switch in your in somebody's house, if you've ever seen those dimmer switches where you can turn the light on and off, but then you can also have it on but different levels of brightness. So that would be an example of an analog signal. So electricity can flow through the signal, but when you vary the amount of electricity that's flowing through, it makes the light bulb dimmer or brighter depending on how much electricity. So you're telling the light bulb how bright to be by changing the amount of electricity that's flowing through. So that's called an analog signal, and we'll work with analog signals tomorrow as well. A digital signal, on the other hand, it works by turning the power on and off in a circuit. So you put some electricity through, then stop it, then put it through again, and then stop it. And you do that over and over in a pattern that the other end of the circuit, or wherever you're trying to transfer information to, that it understands that pattern. So most light bulbs, you could come up with a pattern to say, hey, 50% brightness, like I'll turn the electricity on and off 3 times in 1 second, and that means go to 50% brightness. Most light bulbs aren't built that way until like pretty recently. There are some that use digital signals, but digital signals are mostly what computers use. So you have one level of electricity, but it turns on and off really fast to transfer information. So we won't work with digital signals again, but just know that there's a difference between analog and digital signals. So to read an analog, we will talk about reading digital signals on the microbit as well. But so to read analog and digital signals on the microbit, we use the pins tab. So if you go back to the website and you go to analog and digital signals on the microbit, go ahead and follow some of that. Go ahead and follow the instructions there that talk about the 0, 1, and 2 pins, and simulate kind of reading a analog and digital signal. So once you're done, so you can pause the video for that and then come on back. Alright, so hopefully you had a chance to kind of simulate reading an analog and digital signal on the microbit. Today we went over quite a few things. So we talked about what an electrical circuit is. We talked about how you could complete a circuit using the microbit. We talked about open and closed circuits, and then we talked about analog and digital signals. So tomorrow we're going to learn all the stuff that we've learned so far this week. We're going to have to combine all of that knowledge, and we'll actually create we'll program the microbit to tell us when we need to water a plant. So I will see you tomorrow.